my name's Pete Muir. I'm a software engineer with Red Hat. At Red Hat, I work on a number of things, including the context and dependency injection specification, which is part of the Java EE platform since Java EE 6. Today, I'm going to tell you a little bit about some of the new features we've put into CDI 1.1. For CDI 1.1, we've really focused on enhancing what was there and adding capabilities to the existing APIs. The feedback we got around CDI 1.0 was that people were pretty happy with the basic programming model. They liked the capabilities, they liked the APIs, but there were a few rough edges, a few areas on which we could improve. So that was the focus of the expert group for the whole of the CDI 1.1 series. But before we talk any more about CDI 1.1, I just want to give you a little bit of an introduction to what CDI is and tell you where you can go to find out some more. CDI 1.0 was introduced in Java EE 6, and it's really quickly become one of the most important parts of the platform. So for Java EE 7, we really focused on integrating it more deeply into the platform, adding more integrations to different components, different specifications that make up Java EE. But what makes CDI unique is that it is a type-safe approach to dependency injection that also takes into account the context of which the code is running. So, for example, if you're running in a request, if you're running in a session, if you want to scope something to the application, you can do all of those things. It also includes a number of other facilities besides dependency injection, such as an event system, which allows easy decoupling of code. It has interceptors in it for all components, similar to the interceptors that were introduced in the EJB 3.0 specification. And it has support for decorators, which are a special kind of interceptor that allow you to add capabilities to specific types. These work very, very similarly to the decorator pattern if you're familiar with that. If you want to learn more about CDI, we have a website, www.cdi-spec.org. This website has details of the specifications where you can go and access the specifications, news about what's going on with CDI, and probably most importantly, a set of FAQs so you can go and find out what other people have struggled with CDI, understand a bit more about, some of the common problems that people encounter. We also want to add a tutorial to this site, so if you are interested in helping out writing a tutorial about CDI, then please do get in contact with us and let us know. Definitely want to try and build it out as a community project. So the first enhancement I want to talk about with CDI 1.1 is the global enablement of interceptors, decorators, and alternatives. I should say that throughout this presentation, I'm going to be going straight into code and talking very much about, how you can use these enhancements to really get going with them. And I'm going to give you a little bit of the background around the motivation and the reasons we decided to go the way we did with the design work. On all of these slides, I've tried to highlight what's new over CDI 1.0 with the background yellow color, so you can see very quickly what the particular change is. So with interceptors, decorators, and alternatives, let me first explain the problem and then tell you about the solution that we came up with. So the problem that we had was that in CDI 1.0, interceptors, decorators, and alternatives were only enabled for a particular jar of your deployment. So if you had a war, it would be enabled for that particular war. If you put libraries in the war, it would be per library. If you had EJB jars, it would be per EJB jar. And the reason for this was because we didn't have a good solution to globally order these things across the entire application. And this meant that the CDI 1.0 expert group decided that the only way to handle this, because they didn't have time to investigate a good solution for a global enablement of these artifacts, would be just to allow them to be enabled on a per-jar basis and ordered on a per-jar basis. We spent quite a bit of time for CDI 1.1 looking at the best way to do a global ordering, and we really considered three possible solutions. The first solution we had was the one that we went with, which is a simple numeric ordering. This is very similar, for example, to the way that the init system works in Linux, various variants of Unix, where you simply give each thing a numeric ID, and the larger the number, close to the top of the stack it's called. We also considered a relative ordering solution, where you can say that, for example, if you have the monitoring interceptor that we have on the screen, that should become, say, before a logging interceptor, but after a validation interceptor. And then the final solution we considered was one where you could actually have a list of all of the registered interceptors or decorators alternatives, and then perform some kind of manual sort on them, perhaps using a comparator or, just reordering the list by changing the index of the item in the list. We quickly decided that the third option, the manual sorting, was a good one to go with, regardless of where we went with the other two, because it's kind of like something you can do outside of the main programming model, and something you can do as a good SPI that gives people a lot of power. And the great thing about it is it also allows a library or an extension to define alternative approaches to doing the ordering. So then that left us with the first two options, and we debated between them. And after a lot of thought, we decided to go with the first option, the numeric system. We just felt it was simpler. Both options introduce quite a lot of coupling between interceptors, decorators, alternatives in your code, because they do require an understanding of what other artifacts are registered with. If you use a relative ordering, then you're saying that you're relative to other things that might be in the system. Numeric ordering, it's more implicit, but it still requires knowledge of where other things are in the system. So we decided, look, let's just go with a simple one, a numeric-based system. It's well proven, as I said. It's been around for a very long time, well known. So that was the solution we went with. You've got two, as I said, and you also, of course, have the way you can reorder these things through the SPI. As you can see, we also added in a number of static variables, such as the one I'm using on the screen, application. So this is going a little bit further than just defining a numeric ordering. We also define some recommended ranges you can use. So, for example, if you're writing an application and you want to define an interceptor, we'd recommend you use the application range. This is a numeric range between 2,000 and 3,000. You also have a library range, which is recommended for anyone writing a framework or a library for Java EE, and then a system range, and this is recommended to be left alone and only used by other Java EE specifications. This, we feel, gives a good amount of guidance to application developers and library developers about what kind of priorities they should be using. If you want to use something in the range, we'd recommend you use, for example, application plus 500. Here we see the same thing, but for a decorator rather than for an interceptor. Works in exactly the same way. We'd recommend using the application plus or minus a certain volume, or framework plus or library plus or minus a certain number to get your interceptor into the right position. A number of Java EE specifications are starting to use the priority annotation. So, for example, beam validation defines a validation interceptor, and that's using the priority annotation. The priority it uses is well defined in the specification. Here we can see the same thing we can do with alternatives. Of course, alternatives are a little bit different because, unlike interceptors, they're not being invoked in a stack. They are simply, a number of different options, and only one can be chosen. We can't have multiple being used at the same time. So with alternatives, rather than saying it determines the position in the stack, we say that the priority simply defines the one that will be selected. So the one with the highest priority will be selected. So that means you can have multiple enabled alternatives, and the one with the highest priority is the one that will be used. The next feature I want to talk to you about is decorators for built-in beans. This is pretty straightforward. In CDI 1.0, you could use decorators on your own beans, the ones that you created. In CDI 1.1, we added the ability to attach a decorator to any bean that the container provides. This is pretty powerful because it allows us to do things like actually alter the way that the user transaction object works, alter the way that various validation objects work, etc., etc. So you can really start to do some quite interesting and exciting things inside your framework code. Here we have the new feature of event metadata. This is pretty useful because when we started to look at how we could bridge the event system to other eventing systems, so as you guys know, there's a much more complex and much more complete event system in Java EE called JMS that's great for doing message-driven programming, and especially where you need things like durability and things like that. JMS is the way to go. But CDI has a very nice API where you can do the whole thing inside the programming model very neatly. But of course, when you want to start to bridge these two models, you need to know quite a lot about the way in which the event system works. So by adding in the event metadata object, we are able to give integrators a lot more insight into the way in which the event was fired and lots of metadata about the event. This shows a really nice feature of CDI and a really good way you can extend the CDI programming model. Because event metadata is a new object, and because it's being injected here, we didn't have to change any APIs or break any backwards compatibility in order to add a powerful new feature like this. The next feature we had added was transient references. So in CDI 1.0, you were able to inject things into your constructors, inject things into initializer methods, inject things into various different types of methods and constructors. But often, as you know, when you're creating some kind of manager class or factory class, you don't actually need to store a reference to the object you inject. You just need to call a method on it, perhaps to create another object. CDI 1.0 went a little too far with its requirements around passivation and serialization and validation of passivation and serialization, and said that any object which was injected into a passivating bean, like a session scope bean, must itself be passivating, capable of being passivated. Which, of course, if you think about what I just said about, the common pattern of wanting to inject an object, call a method on it, and store the result of calling that method, this is just going a little bit too far because, we might well be throwing away the reference to the object we injected, but keeping a reference to something that it gave us inside the bean. So we added the transient reference annotation, which you can apply on a constructor parameter or on a method parameter that's being injected. And this just tells the container, throw this reference away after this method or constructor completes. You don't want to keep it around. If you try and store this inside your bean, you're going to have problems because the reference is going to be discarded at the end of the method call or at the end of the request or whenever it makes sense. But it does mean that the passivation validation that would normally be applied to this object won't be applied. So you can safely inject it, have your bean pass validation, and use that reference later on. A pretty simple feature we added was callbacks, so that you know when the scope, like the session scope I'm showing here, starts or ends. So that allows you to really easily do something like log when a session starts, or perhaps react when a session ends, perhaps do some extra clear up around a user, or add a last date or a last login date. Again, using the CDI event bus, really, really easy to add, all sorts of callbacks like that into the specification. You can do this by using the initialized qualifier with the session scoped type as the value. If you want to decouple your application from the underlying session management system or the underlying context management system, you can just observe an object. Or if you want to get some extra information about the session or the request or whatever it is that was being started or ended, you can also observe the object that associated with that context to get that extra information. So you've got two choices there. Loosely coupled, observe an object, or slightly more tightly coupled, observe the underlying HTTP object. Obviously, couple your code more tightly to HTTP. A big new feature we added was around CDI activation. The most common problem that I ever saw around people trying to use CDI was that they forgot to put the beans.xml marker file into their jar or into their war or into their EJB jar or whatever. This marker file was used to indicate to the container that CDI should start. And we had a lot of people saying, I don't want to have to add this file. And then the second problem people came up with was, well, I don't want all of my classes in the jar to be scanned. I just want the ones that I annotate somehow to be scanned. I want to explicitly select the ones that should be scanned and should be available as beans. So we fixed both of these problems in CDI 1.1 by defining inside a Java EE server, any class, regardless of whether there is a beans.xml in the archive, will get picked up, but only if it has a scope annotation on it. So, for example, request scoped, session scoped, dependent scoped, application scoped. But the nice thing is, as you can see from my slide here, you don't need to put that beans.xml file in the archive. So CDI is now active everywhere, but it's only active everywhere for beans that have a scope annotation on them. The old approach of putting a beans.xml in a file and having every class available still works. This can also be altered in a programmatic way when the container starts by passing in some kind of flag. That's container specific. You've got control over this through the SPI, so you can also add and remove certain classes as you go. A feature that we added as well, very closely related to the activation and disablement of CDI archives, was the ability to specify in XML what should and shouldn't be scanned. So I've got a couple of examples here on the screen that give you an understanding or give you an idea of all the different options available. So you can exclude individual classes, you can exclude a package, or you can exclude an entire tree of packages. This exclude syntax is very, very similar to the way the ANT globbing syntax works, so hopefully that should be familiar to everyone. We've also got the ability to only activate this exclude in certain situations. So, for example, we can say the exclude is only active if a particular class is present on the class path, or if a particular class is not present. That's another option. Or we can do this based around system properties. So we can say if a system property is defined, then the exclude filter is active. Or we can also say if a system property with a particular value is defined, then the exclude filter is active. And if that system property was not defined, the exclude filter would not be active. The final one around including and excluding beans from being deployed is the vetoed annotation. This is very simple. You just put this on a single class. Once you put it on the class, that class will be ignored by the CDI container. It won't be defined as a bean, it won't pass through the SPI, etc. So a really good example of that would be the utils class that we have here. Often you put some kind of utility class in your application that just has static members on it. Or having that instantiated as a bean is just confusing. You never want people to inject that, so you can just add the vetoed annotation to it. Another good example might be entity beans. Entity beans, you often don't want to inject an entity bean. So in that case, we'd recommend putting vetoed on your entity beans to make it really clear that this shouldn't be available for injection by CDI. Another good example of where you can use vetoed, or where we'd even recommend you use vetoed, is if you're writing objects like servlet listeners, like servlet classes. You can't inject that servlet class into your application. That servlet class is going to be used by your web server. So again, we'd recommend putting the vetoed annotation on that class to indicate both to you, to other programmers, and to the container that it should never instantiate an instance of that class to inject. The final area I'm going to talk a little bit about is ways in which you can use CDI as a framework integrator or as a library writer, and some of the major enhancements we've added there. There have been a lot of improvements to the SPI, and I'm really only going to give you a brief flavor of some of the really important ones. You need to check out the spec in order to find out more about that. One of the major complaints from library writers about CDI was that you couldn't easily instantiate a new instance of an object that wasn't managed by CDI. You have your own object, or you have an instance that you want to create on demand for perhaps use in another library. And, how do you do this? How do you do this in CDI? And in CDI 1.0, it did require quite a lot of complicated callbacks to the bean manager object to do this. So for CDI 1.1, we added a utility class to the API called unmanaged. You simply instantiate it using the new keyword. You then can call the new instance method on it, which will give you an instance of the object. And then you can do things like call produce on it to create a new instance, call inject to inject its fields, call postconstruct to call the postconstruct method, etc., etc. And of course, you've got your cleanup methods that you can call after you've finished using the instance. This is very useful if you've got a bean that you need to access, as I said, outside of the CDI environment and outside of the CDI lifecycle. So the idea very much here is that this is not for beans that you want to have managed by the CDI container, but beans you want to manage the lifecycle of yourself. So if you're implementing some other kind of lifecycle where you manage the instance lifecycle, then this is the approach to use. You may be wondering why we split into unmanaged and unmanaged instance. Well, the answer is pretty simple. The unmanaged class gives you access to all the metadata about the instance. The unmanaged instance class gives you access to the actual particular instance. So you could, in fact, store the unmanaged object in your application and reuse it time and time again. Still on the topic managing instances and accessing instances, we added in the CDI utility class that gives you access to the current container. So to get access to the current container, you could, of course, use Jundi. But if you want to use a programmatic approach, especially useful when, if you're operating outside of Java EE when Jundi is not available, this method offers an alternative approach. You can call CDI.current from anywhere, and this gives you access to the CDI container wherever you are. You can use this straight away to start getting hold of instances. Once you've called CDI.current, it looks very like the instance interface that you have in CDI. This allows you to select types based on their type, based on their qualifier, and then call get in order to get hold of an instance. You can also get the bean manager this way. And this is how the unmanaged class that I showed you in the previous slide actually works. This is how it gets access to the current container, is it will use the CDI.current system. I should mention that CDI.current is pluggable. So, for example, if you're running in a different container, you can always change the approach that's used to look up the current instance of the container. Why is this approach a bit different to the previous one? Well, the previous one is very, very useful if you're writing a framework and you want to manage the lifecycle of the instance yourself. Whereas on this one, the lifecycle is still going to be managed by the CDI container. So just slightly different use cases. This might be more useful if you're just writing an application, need to do something outside of CDI container, when the previous one is very useful if you're managing the lifecycle yourself. Also on the topic of the SPI, we added the AfterType Discovery event. So lots of people have been really interested in using the CDI SPI because it allows you to easily scan the types that are in the archive, because it gives you a callback for every single type that's in the archive. So lots of people were using this to actually start to do a scan and to see what was there. But in CDI 1.0, there was no way to react and add other types after this scan. So for example, you might want to do a scan, and say, well, this type isn't present, so I'm going to add it. That would have been very difficult in CDI 1.0. You had to do a number of different tricks in order to do that. In CDI 1.1, we've made this very easy by simply adding the AfterType Discovery event that gets called after all types have been discovered and allows you to add additional types into the system. You can also use the AfterType Discovery event to do the reordering of interceptors, decorators, and alternatives like we discussed right at the top of the presentation that allows you to alter that priority-based ordering. Final feature I'm going to talk about that we added to the SPI is the with annotations annotation. This is really here to give us a bit of a performance boost. When people started to use the process annotated type event, they were, as I said, very interested in it because it allowed them to easily scan what was there in the application. But of course, if they were looking for a type with a particular annotation on, this did actually require them to observe every single process annotated type event and then do a loop over all the methods and all the parameters and all the methods to see if a particular annotation was present on any parameter of any method of the class. Of course, all those loops starts to get pretty slow. And it's really unnecessary because this is information the container has. It does tend to know what annotations are present where on what types. So we added the with annotations annotation, which allows you to say, only call this event if this particular annotation is present somewhere on the type. You're still going to need to go through the type and evaluate where the annotation is present and do the work based on that. But at least it means you don't get notified of all types. You only get notified of those particular types that you are really interested in. We believe that with this enhancement that it should really just speed up the bootstrap of CDI when you've got lots of extensions present. So in conclusion, what would I say the major changes in CDI 1.1 are? Well, I think the global activation enabling CDI throughout Java EE is probably the biggest change. The global interceptors, decorators, and alternatives is a much requested feature, and I think this is a really good solution to it and should make these things considerably more useful. And of course, we've talked a lot about some of the SPI improvements that are available. Again, one of the real strengths of CDI has been its ecosystem of libraries and frameworks. And so I think having a stronger SPI will really help CDI 1.1 Java EE 7 and to help it to integrate and build an even greater ecosystem for Java EE. So to find out more information about CDI, I'd recommend visiting our website, www.cdi-spec.org. Thank you very much for listening. I hope you enjoyed using Java EE 7, and I'm really looking forward to lots of feedback on CDI 1.1